Assalamualaikum. We are from the group 4. We will be present about the experiment 4, which is application of first and second law of thermodynamics. Our team member is Lokman Hakim, me is Muhammad Shafiq, Hussein Dama, and Nur Anis Nazura. For the introduction, the main objective for the experiment is to apply the law of thermodynamics and the concept of the second thermodynamic law in the process. Also, identify how heat is converted to work in single-stage compressor. For the theory, the first law of thermodynamics is used as a basis for the calculation of heat transfer. It is also used in studying the relationship among the various forms of energy and energy interaction. The first law of thermodynamics expresses that the net change, which is increase or decrease, is the total energy of the system during a process is equal to difference between the total energy entering and the total energy leaving the system during the process. This is the calculation we use for the first law, where M is mass, C is heat capacity, and T is temperature. The closest statement states that it is possible to construct a device that operates in a cycle and produce no effect other than the transfer of heat from a lower temperature body to a higher temperature body. According to the law, heat always flows from a body at a higher temperature to a body at lower temperature. This law is applicable to all types of heat engines, cycle including Otto, diesel, etc. for all types of working fluid in the engine. This law has led to the progress of present day. Part is theory and real application. According to the law, heat always flows from the body at higher temperature to a body at lower temperature. This law is applicable to all types of heat engine cycle including Otto, diesel, and etc. All types of working fluid used in engine. This law has led to the progress of present day in vehicle. Second is air conditioner and heat pump. Follow the similar law of thermodynamics. The air conditioner removes heat from the room and maintains it at lower temperature by throwing the absorbed heat into the atmosphere. The heat pump absorbs heat from the atmosphere and supplies it to the room, which is cooler in winter. The third is in crowded place. Sweating in crowded room, in everybody, which is every person, starts sweating. The body starts cooling down by transferring the body heat to the sweat. Sweat evaporates, adding heat to the room. Again, this happens due to the first and second law of thermodynamic in action. One thing to keep in mind, heat is not lost but transferred, attaining equilibrium with maximum entropy. The lastly is melting of ice cube. Ice cube in a drink absorb heat from the drink, making the drink cooler. If we forget to drink it after some time, it again attains room temperature by absorbing the atmospheric heat. All this happens as per the first and the second law of thermodynamics. Now I will present the presentation to my member.
Okay, Assalamualaikum warahmatullahi wabarakatuh. I'm Lokman Hakim. So I will present about the apparatus and methodology. So we go through the apparatus first. So this is our apparatus for the experiment. For the first one, we have kettle, beaker, wagger, stopwatch, container, thermometers, and balance. Okay, that is the apparatus for the experiment. We move to the procedure of the experiment. Okay, for the number one, the water was heated using kettle. Number two, the empty beaker was weighed. Number three, the hot water was filled into the beaker and the weight of the beaker was recorded. The container was filled with cold water until it reached the same level with hot water and the weight of cold water was recorded. Number 5, the beaker that contained hot water was placed into the container. And the last procedure that is 2 thermometers were placed into hot water and cold water respectively, and both temperature of water every 1 minute were recorded until reach equilibrium. Okay, that's all for the methodology. Thank you.
Hello, my name is Hussein Dama. This is my bar result, and this is the table we will get from the data we did in the lab. And we did time 1 minute and 14 minutes, temperature of hot water, temperature of cold water, mass of empty beaker is equal to initial temperature of cold water is equal to 30 degrees. Initial temperature of hot water is equal to 100 degrees. Mass of beaker plus hot water is equal to 253.6 grams. Heat capacity is always constant and it is equal to 4.187 kilojoule per kilogram times K. Calculations. Mass of empty beaker W is equal to mass times gram. 166.7 times 9.871,633.66. Weight of beaker is equal to 1,633.66 gram. Mass of empty beaker plus hot water. Hot water is equal to 253.6 minus 166.7 is equal to 86.9 gram. Mass of hot water is equal to 86.9 divided by 100 is equal to 0.0869 kilogram. Mass of cold water is equal to 30 degree divided by 100 times 0.0869 is equal to 0.026 kg. And determine the energy difference between hot water and cold water. Okay, so we have energy. We have energy balance of hot water is equal to MCV bracket T2 minus T1 bracket hot times hot water. So energy balance for hot water is equal to 0.087 K times 4.887 kJ per kilogram times K times 37 plus 273.15 minus bracket 65 plus 273.5.15. So this 37 is initial is the last one and this 65 is the initial one. So energy balance for hot water is equal to negative 10.19 kilojoule and energy out. So energy balance for cold water, we use the same equation and we got energy balance for cold water is equal to positive 0.5464 kilojoule energy in.
My name is Nur Anis Nazura. I will present about the discussion of this experiment. This is our graph that have been plotted based on the data that we get. During the experiment conducted, it was observed that the temperature of hot water dropped significantly at the beginning stage for the first 6 minutes. There is a temperature change due to the heat transfer from hot to cold water. Since hot water releases energy, the gradient is negative. Cold water have positive gradient as it absorbs energy from hot water. Hence, we can prove that it is obey the first law of thermodynamics. We also observe that the temperature of hot water decreased with time, meanwhile the temperature of cold water increasing. It was proven that it obeys the second law of thermodynamics, which is heat transfer from high temperature to low temperature. When both water reached the thermal equilibrium temperature, there was no heat transfer process. That is the reason why the temperature change for both water at this moment is 0. Eventually, both water achieve thermal equilibrium where both have same temperature and no heat transfer between them. I will pass to the next presenter.